Hello. Okay, we are on 1.2 segments and congruence. Okay, so go ahead and go to that in your notes. And here we go. Okay, so we're going to start with postulate and axiom. So again, we're going through more definitions, right? So this is a rule that is accepted or taken without proof. A theorem is a statement that has been proven to be true. Okay, postulate number one. This is the ruler postulate. It states that the points on a line can be matched up one-to-one with real numbers. The real number is called its coordinate. This doesn't mean that it has to be on a coordinate grid, guys. It just means that that's its coordinate. So for instance, if I have this line, and I have A on the line, and I have B on the line, this is coordinate 1, this is coordinate 2. To find their distance on the ruler, we do B's point, whatever number it is, minus A's point, whatever number that is. Congruence. So congruence kind of means the same, right? So it means that it's the same size and the same shape. So this blue sticky note is congruent to this pink sticky note. Okay, same size, same shape. So almost equal in another sense. Two segments are congruent when they have the same length and are marked with tick marks. Okay, so getting into more notations. To show congruence, since it's similar to being equal, we do an equal sign, but we do like a little tilde over it. So that means congruent. Okay. If I have a segment here and I say that it is the same length as this segment here, an easy way to do that is to put this little marking into both segments to show that they are congruent. When stating a segment's measure, we use equal. So the measure, we use equal. So like the measurement of AB equals 4 centimeters. That's its measure. But when we're stating that two segments are congruent, so let's say this is AB and this is CD, we use the congruent sign. So we would use AB is congruent to CD, meaning their lengths they're the same size and same shape. But measurement, it's equal to. Okay? Use the ruler postulate to calculate the following segment lengths. Go ahead and pause me and solve for A, B, C, D, and number 2. Unpause me when you're done to check yourself. Okay, so hopefully you've done these. AC, so A to C, -4 minus -9. Two negatives make a positive, so all I did was C is at -4, A is at -9, so I take my furthest, subtract my smallest, and I get 5. C to D, so I do 0 minus -4, two negatives make a positive, so that is a 4. D to C, same thing. Isn't C to D the same as D to C? They are. So it's actually the same exact answer. B to E, so I'm going to do 2 minus -6. Two negatives make a positive, so I get 8. Use the number line above to state two segments that are congruent to each other. Well, this guy is 3, this guy is 2, this guy is 4, and this guy is 2, right? So it looks like segment BC is congruent to segment DE, because they are both equal to 2. their measurement, so BC measurement equals 2. All right, so given the coordinates below, are the two stated segments congruent? Why or why not? So you have to remember how to plot points, right? So e.g., E is at -3, 4, so I start at 0, 0. So that tells me go back 3 and up 4. I'm going to label that point E, so I know what I'm talking about. G is at 2, 4, so I'm doing E to G. So over 2, up 1, 2, 3, 4. And so we're talking about this segment. That segment is 1, 2, 3, 4, 5. 5 has a length of 5. The other segment that they're talking about is F to H. F is at -1, up 4. So we can call that F. H is at -1, up 1. That's H. Connect those. That has a length of 1, 2, 3. So are they congruent? No. E.g., I'm going to put the congruent symbol, FH, but they are not congruent. So I'm going to say not congruent. EG has a measurement equal to 5. FH has a measurement equal to 3. 5 does not equal 3. Okay? All right. Next page. Postulate 2 is the segment addition postulate. Okay. So if A, B, and C are collinear, so we have to remind ourselves collinear means on the same line, with B between A and C, so they drew a picture. Here's line AC, but we have segment A, B, C, and B is in between A and C. What that means is that I can take the piece of AB, and I can add the piece of BC, and once I've added those pieces, I should get the whole length of AC. And that's what segment addition postulate is saying. This piece plus this piece will equal the whole piece. Okay? So calculate the length of A to C. So A to C is here. So we're going to use segment addition postulate, and we're going to say, okay, A to B, which is 14, plus B to C, which is 3x minus 4, should equal the whole distance, or whole length, of 4x plus 4 of A to C. So now we're going to start solving this. So we're going to combine like terms, same side. So 14 minus 4 is 10, so I have 10 plus 3x equals 4x plus 4. And so now I'm going to start moving stuff around. I'm going to subtract 3x from both sides, because that'll give me a positive x. So I get 10 equals x plus 4. I'm going to subtract 4, so I get x equals 6. But that's not what they asked for. They asked for us to calculate the length of AC. All I've calculated at that point is the value of x. So if I want to calculate the length of A to C, that's the big length, I have to plug in 4x. I have to plug in that 6 that I found, and then I add 4. So 4 times 6 is 24. 24 plus 4 is 28. That is your final answer. So AC equals 28. Not congruent to 28, but it equals 28. All right. Point J is in between points G and H on segment GH. So geometry, it is so important that you guys draw pictures. You are going to draw more pictures in geometry than you've probably ever drawn in math before. When they tell you stuff, the way to solve it is to first have a picture there, because if you're not drawing that picture, you're going to have to try to keep that picture in your head, plus do all the math, and it's just going to get super confusing. So always draw pictures. Point J is somewhere in between. It doesn't say that it's halfway in between. It doesn't say where it is, but it's somewhere in between it. Okay? G to J is 2x squared minus 3. J to H is x squared minus 4. And this whole distance is 7x plus 13. So again, we're going to use our segment addition postulate. This segment plus this segment equals the whole thing. So 2x squared minus 3 plus x squared minus 4 should equal 7x plus 13. Now, this one's a little tricky I want for you to pause me and I want you to truly solve for x. See if you can do it. My clue to you on this is think about our review unit and you're going to be using that. Unpause me when you're done or if you get stuck. Okay? So, hopefully you've tried it at this point. I'm going to start getting everything to the same side to set it equal to 0. So I'm going to subtract 7x and I'm going to subtract 13. I'm also going to combine my like terms of 2x squared and x squared. So 2x squared and x squared, that's a 1x squared, right? Gives me 3x squared. Negative 3 and negative 4 make a negative 7. I'm actually going to do those two steps before I move this stuff. Now I'm going to subtract 7x, but there's no x terms over here. So I'm going to put that in the middle. So I'm going to do 3x squared minus 7x. I'm also subtracting 13. So negative 7 minus 13 is negative 20. Now it equals 0. We are going, so this is a quadratic. I'm going to factor, and I'm going to see if it factors. So I'm going to crisscross it. I'm going to multiply a times c. So 3 times negative 20 is negative 60. So I need two numbers that multiply to negative 60 that add to negative 7. All right, so I know 12 times 5 is 60, and I know some combination of 12 and 5 make negative 7. 12 would have to be negative, and 5 would be positive. So now I'm going to rewrite this guy. I'm going to keep my first term, 3x squared. Instead of writing my second term, I'm going to use these two numbers that I just found, so negative 12x plus 5x, and I'm going to bring down my negative 20. I'm going to group, 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 GCF both of them. So 3x can come out of that, and I'm left with x minus 4. 5 can come out of here, and I'm left with x minus 4. Now my quick check is that this guy should be the same as this guy, and it is. So my two terms are x minus 4 and 3x plus 5. Okay? At that point, I still have not solved for x. That is equal to 0. What we do at that point is we set both of those equal to 0 to solve for each of those. So I do x minus 4 equals 0. I hope you guys can see that. And 3x plus 5 equals 0. I add 4 to both sides here, so I get x equals 4. I subtract 5, so I get 3x equals negative 5. And then I divide by 3, so I get x equals negative 5 thirds. Those are your two answers on that. There's a lot of quadratic math there, huh? Hopefully I didn't go through that too fast. So if I did, stop me whenever I'm going through it so you can catch up to where I'm at and make sure that you understand it. So that's all for these notes. There will be a 1.2 homework Schoology assignment in Schoology, so you need to complete that. Let me know if you have questions, and I will talk to you guys later. Bye.